100% of the historical significance of a derelict military vehicle is often hidden beneath a thick layer of oxidized iron and decades of sediment. Why do these rusted skeletons of industrial engineering continue to surface in the most remote corners of the globe 80 years after the cessation of hostilities? The discovery of a weathered chassis in a dense forest or a forgotten ravine immediately triggers a sequence of technical inquiries regarding its origin, its specific manufacturing year, and the specialized role it played within the massive logistics chain of the Second World War. But in reality, the answer lies in the desperate atmospheric conditions of the front lines, where standard equipment often failed to meet the brutal demands of the terrain. Logistics during this era demanded a level of reliability that surpassed the requirements of pure firepower. Engineers were forced to abandon conventional designs in favor of off-standard builds and experimental configurations that often resulted in unconventional silhouettes. One can notice how the structural geometry of these rare vehicles deviates from the mass-produced norms, reflecting backstories that remain buried until specialized historians perform a deep technical excavation of the remains. This process is only gaining momentum as more sites are uncovered. The complexity of these finds increases with every recovery operation, as the equipment gradually reveals its secrets through serial numbers and frame reinforcements. The Dodge WC62 6x6 stands as a primary example of this rugged evolution in tactical transport. Dodge manufactured these three-axle machines in the United States between the years 1942 and 1945 to serve as high-capacity troop carriers. Why did the military transition from the standard four-wheeled configurations to this more complex six-wheeled design? The answer is found in the shifting requirements of the European and Pacific theaters of operation. As the Allies expanded their campaigns, the need for increased load capacity and superior off-road performance became a critical engineering priority. It is visible how the elongated frame of the 62 model allowed for a significant increase in the volume of soldiers and equipment transported across unstable soil. Everything only gets more complicated when analyzing the mechanical heart of these machines. An inline six-cylinder engine provided the necessary torque to drive all three axles simultaneously, ensuring that the vehicle did not lose momentum in deep mud or sand. The process of manufacturing these specialized trucks required a complete retooling of assembly lines to accommodate the extra axle and the reinforced suspension systems. Glides along the heavy steel rails of the chassis, where the original olive drab paint occasionally peeks through the corrosion. It does not end at this stage of the investigation. Each discovery serves as a physical record of the industrial push that defined the early 1940s. The metal remains in a state of suspended animation, waiting for the moment it is identified and documented within the archive of heavy transport history. Thus, the technical legacy of these forgotten machines is preserved through the study of their unique mechanical structures. 92 horsepower is the output generated by the six-cylinder inline engine found beneath the hood of the Dodge WC62. Why was such a seemingly modest power figure chosen for a vehicle weighing several tons? High horsepower was less critical than torque, which engineers tuned specifically for low-end performance during the initial design phase. This mechanical calibration allowed the machine to navigate muddy terrain and execute steep climbs that would stall a standard road vehicle. But this is just the beginning of its technical capabilities. At first glance, the drivetrain appears to be a standard configuration, but in reality, the 6x6 system transforms the unit into a highly capable off-road platform. A 4-speed manual transmission works in tandem with a specialized low-range gear to manage power distribution across all three axles. It is visible how the leaf spring suspension, installed on every axle, provides a sturdy yet uncomplicated foundation for the heavy chassis. The equipment gradually absorbs the shocks of uneven landscapes while maintaining the utilitarian structural integrity required by the era. Flat body panels and tall fenders define the external silhouette of this legendary transport. The design does not end at this stage, as deep-treaded tires and a canvas-covered open rear section complete the functional profile. Each vehicle possessed the capacity to haul 1 1/2 tons of cargo or transport 12 fully equipped soldiers into the theater of operations. Everything only gets more complicated when considering the sheer scale of its deployment across various global fronts. Extensive use was recorded during the North African campaign, the Italian front, and the pivotal Normandy landings. The process is only gaining momentum as historians analyze the reputation for versatility earned by this specific class of truck. One can notice how the WC63 variant differs from the base model through the addition of a front-mounted winch. This secondary mechanical system was utilized for light recovery and field rescues in the heat of combat. Decades after the conclusion of the war, a single WC62 was discovered in the rural landscape of Belgium. The vehicle sat tucked away inside an old farm shed where vines had overgrown the metal and farming tools surrounded the chassis. One can notice how the truck's frame served a dual purpose as the primary support for a makeshift greenhouse. The landowner remained completely unaware of the historical treasure occupying his backyard for several years. This specific blend of mechanical simplicity and wartime legacy elevates the machine beyond the status of a common utility vehicle. It acts as a time capsule on wheels, preserved by the very environment that sought to reclaim it. The transition to the next level of this story involves another vehicle that traveled half the globe. Its journey ended in a location even more unexpected than a quiet Belgian farm. 94 horsepower is the output generated by the Hercules JXD inline 6-cylinder engine that powered the Studebaker US6. Produced between the years 1941 and 1945 in the United States, this vehicle became a cornerstone of wartime logistics. Why was a truck manufactured in America destined for the remote landscapes of the Eastern Front? While developed on American soil, the US6 was engineered specifically for the Lend-Lease program, a massive initiative to supply allied nations with essential resources. This strategic focus directed the vast majority of these machines toward the Soviet Union rather than Western European battlefields. One can notice how the 5.7 liters of engine displacement provided the smooth, reliable torque necessary for prolonged operations across broken terrain. It seems like a simple transport vehicle, but in reality, the mechanical configuration was a masterpiece of rugged utility. A 5-speed manual transmission equipped with low-range gearing allowed the truck to navigate deep mud and snow. Transition to the next level. The 6x6 drivetrain became the standard configuration for units shipped to the harshest climates, ensuring that momentum was never lost. Sturdy semi-elliptical leaf springs supported the chassis, designed for maximum durability and simplified maintenance in field conditions. The equipment gradually reveals its massive proportions, stretching over 20 feet in total length. A reinforced steel cab sits atop a heavy-duty frame, followed by a wooden cargo bed featuring removable side panels for versatile loading. This construction was optimized for pure industrial efficiency and long-term endurance. But this is just the beginning. The US6 moved everything from infantry and ammunition to fuel, food, and even disassembled artillery pieces. It operated on front lines where paved infrastructure was entirely non-existent. Over 150,000 units were delivered to the Soviet Union throughout the conflict. In these regions, the truck earned the affectionate nickname the Studer among the soldiers who relied on it. The process of its service did not end with the cessation of hostilities. Thousands of these vehicles were absorbed into Soviet civilian life for use in agriculture and construction. It is visible how decades of time can bury such history, as evidenced by a specific unit rediscovered in a rural barn near Irkutsk, Siberia. The truck remained hidden under piles of wooden planks and old equipment for half a century. Only after a group of local collectors cleared the debris was the legendary silhouette finally identified. Everything only gets more complicated as one examines the interior details of the find. On the dashboard, hand-carved Cyrillic markings remain clearly visible in the metal and wood. These inscriptions were likely left by a Red Army driver who spent months behind the wheel during the height of the war. At first glance, it is a piece of rusted machinery, but in reality, it is a preserved record of a human journey. And this is not the limit of such discoveries. A massive truck of even greater proportions remains abandoned in a dense forest where time has effectively stood still. The Studebaker US6 leaves the barn as a recovered relic, transitioning into a calm stage of preservation. 7.5 tons is the official load rating of the heavy-duty 6x6 prime mover manufactured by Mack trucks between 1940 and 1945. Why did the military require such a massive 3-axle configuration for its mobile operations? It only looks obvious to call it a transport vehicle, but in reality, it was a specialized artillery prime mover engineered specifically to haul oversized weaponry like 155mm howitzers and long-range field guns across broken terrain. Speed was never the priority for this machine, as the design focused entirely on brute strength and battlefield resilience. 170 horsepower is generated by the Mack NO inline 6-cylinder engine vibrating beneath the reinforced steel hood. The massive power plant displaces 707 cubic inches, which is equivalent to approximately 11.6 liters of volume. One can notice how the torque curve is tuned specifically for moving extreme weight rather than achieving high velocity. This engine is mated to a 5-speed manual transmission paired with a heavy-duty low-range transfer case to provide raw pulling power. It gets more complex further on. 6x6 drivetrain mechanics work in tandem with a reinforced leaf spring suspension system to ensure stability even when towing the heaviest ballistic loads. Visually, the machine presents a towering profile defined by an exceptionally long hood, oversized fenders, and a steel cab that carries an armored appearance. Massive military tires provide the necessary ground clearance for deep mud and shell craters. At idle, the engine produces a deep growling rumble that signals the immense mechanical potential of the internal components. The process of deployment saw these vehicles utilized heavily across Western Europe and throughout the Pacific theater of operations. Everything only gets more complicated when considering the logistical demands of moving critical weapons and heavy equipment during active combat. Because of this inherent legacy of structural strength, many units remained in active service at various military bases well into the 1950s. But this is just the beginning of the story for some specific chassis. One remarkable example of this engineering was discovered decades later in the dense forests of southern Romania. The area was so remote that a dedicated team of enthusiasts had to trace old wartime transport routes for days just to narrow down the coordinates. It is visible how the vehicle sat partially buried in the earth, with only the upper section of the cab protruding from the mud. The equipment gradually became part of the landscape over the passing half-century. A tree had actually grown up directly beside the truck, eventually bending one of the heavy steel doors as the trunk matured over several decades. This physical obstruction serves as proof that the vehicle had remained completely untouched since it was first abandoned. Inside the cab, original branding and a speedometer still marked in miles per hour remained intact despite the humidity. Tools scattered across the floor confirmed the identity of the machine as a heavy-duty relic frozen in time. The metal is ready for a new chapter after enduring years of environmental exposure in the wilderness. Transition to the next level. A European-built machine follows, representing a design so far ahead of its technical era that it remained in active production for decades. The material transitions into a calm stage as the history of the prime mover is documented. 6x6 is the drive configuration of the Tatra 111, a vehicle that began its existence in 1942 within the borders of occupied Czechoslovakia. Why did the German military commission such an ambitious engineering project during the height of the conflict? Logistics across extreme and unforgiving terrains required a specialized solution that standard transport could not provide. But in reality, the design proved so advanced that production continued for over 20 years after the conflict ended. It served the needs of nations throughout the entire Soviet bloc until the 1960s. The process is only gaining momentum within the chassis of this heavy-duty machine. One can notice the massive 14.8-liter displacement of the air-cooled vertical 12 diesel engine. It generates approximately 210 horsepower while maintaining a rhythmic industrial-sounding hum. This sound resembles a stationary power plant more than a standard transport truck. Air cooling in a vehicle of this significant size was exceptionally rare for the era. It only looks obvious to use liquid cooling, but in reality, air cooling made the truck far more reliable in freezing mountain climates and across frozen plains. The equipment gradually overcomes temperature extremes that would burst the radiators of conventional vehicles. It gets more complex further on as the power reaches the wheels. The camera glides along the drivetrain consisting of a 5-speed manual transmission paired with a specialized low-range gearbox. 6x6 all-wheel drive combined with independent swing axle suspension defines its mechanical architecture. This specific suspension design was a hallmark innovation that granted the machine exceptional off-road capabilities. One can notice how the wheels move independently to maintain contact with the surface. Boulders split with a crack and mud yields as the vehicle crosses shallow rivers and thick snow without any mechanical modifications. Visually, the machine presents a striking profile. The long, low-slung hood contrasts sharply with a narrow, angular cabin designed for rapid assembly and structural protection. Everything only gets more complicated when considering its sheer physical scale. 13 tons is the total weight of this steel giant, which measures over 26 feet in length. During wartime operations, it moved across cold and mountainous fronts to deliver fuel, heavy mechanical parts, and ammunition. In specific instances, it even transported light tanks across rugged sectors. But this is just the beginning of its long service life. After the war, the vehicle transitioned into a standard utility role across Eastern Europe. The equipment was deployed in the demanding sectors of forestry, heavy construction, and large-scale mining operations. It is visible how these machines became the backbone of regional reconstruction and industrial expansion. One specific unit was discovered decades later in an abandoned sawmill located in Slovakia. It lay buried under layers of old tools and cut timber after serving its final years as a makeshift generator for a mechanical hoist in the 1970s. At first glance, the machine appeared to be a relic of the past, but in reality, its mechanical integrity remained intact. The most surprising detail was that the engine still turned over despite 40 years of sitting idle. Minimal intervention is all a local engineer claimed would be necessary to fully restore the vehicle to operational status. The clutch remains stuck in a neutral position, preserving the internal components from total seizure. Transition to the next level of heavy hauling. The following vehicle was not merely powerful, as it was specifically engineered to tow massive tanks without using conventional means. 102 horsepower is the modest output generated by the Gardner 6LW engine powering the Scammell Pioneer R100. Why did the British military rely on such a low-powered unit for their most grueling heavy-duty tasks? While the horsepower figure seems small, the inline 6-cylinder diesel engine with its 8.3 liters of displacement produced massive torque at exceptionally low revolutions per minute. This specific mechanical configuration provided the brute force necessary for traction and control under extreme loads. But this was just the beginning of its specialized engineering. The transmission was designed with 6 manual speeds. One can notice how the first and second gears are geared extremely short to facilitate hill starts, while the vehicle is fully loaded to its maximum capacity. It seems simple at first glance, but the rear-wheel drive 6x4 configuration relied on wide tires and a reinforced semi-elliptic leaf spring suspension to maintain grip. This combination allowed the truck to traverse mud and broken terrain that would immobilize standard transport vehicles. The equipment gradually overcomes obstacles through mechanical advantage rather than pure speed. 8.3 liters of displacement allowed this late 1930s design to break away from every conventional truck standard of the era. The Pioneer R100 was built by the British manufacturer Scammell specifically for hauling heavy artillery and recovering damaged tanks across active combat zones. It is visible how the forward-set cab and tall, exposed fenders create a theatrical silhouette that stood out on the battlefield. The open chassis and massive rear bed were equipped with thick metal rails and structural supports. Everything only gets more complicated when these machines were deployed just behind the front lines. The truck saw continuous action across multiple theaters, from the deserts of North Africa to the muddy fields of Western Europe. It performed critical recovery missions, often while under direct enemy fire, to retrieve oversized loads and howitzers. After the conflict ended, many of these heavy haulers vanished into civilian service or scrap yards. Decades later, a single unit resurfaced inside a stone barn in rural Scotland. It had spent years leaning against a wall, hidden under heavy tarps and rusted chains while serving as a frame for storing animal feed and timber. A manual starting crank was still mounted on its original bracket inside the barn. This was the most surprising discovery for the enthusiast who identified the vehicle, as such components are rarely found even in dedicated military museums. One can notice the layer of dust and rust covering the machine, yet its unique upright front and tall stance remained unmistakable. The manual crank remained perfectly preserved in its place for over half a century. The process of documenting this find allows for the preservation of a machine that once carried the physical weight of history. The vehicle is now recognized as a rare survivor of the Second World War. Its journey from the front lines of Europe to a quiet Scottish farm concludes with its rediscovery and identification. The heavy steel frame and specialized components remain as evidence of an era defined by rugged mechanical utility. The material is ready to move to the next processing phase without haste. 147 horsepower is the output generated by the White 16X inline 6-cylinder engine powering this machine. Why did the United States military choose to combine traditional wheels with a continuous track system in 1941? At first glance, the design looks like a compromise between two different worlds, but without this hybrid configuration, the infantry would have lacked a transport capable of maintaining high speeds on roads while retaining the ability to cross soft, unstable soil. The 6 3/10 liters of displacement provided the specific torque necessary for moving 13 fully armed soldiers and their heavy equipment through mud and sand. The maneuverability of the M3 half-track relies on a 4-speed manual transmission equipped with low-range gearing. Steering is managed entirely by the front wheels, which utilize semi-elliptical leaf springs to dampen the vibration from the terrain. It is visible how the rear track assembly moves over obstacles as the bogie wheels wheels absorb the mechanical impact of uneven ground. This tactical flexibility made the vehicle a staple of the American war effort across the Pacific, North Africa, and Western Europe. One can notice the steel plating of the body, which was designed to provide the crew with essential protection against small arms fire and shrapnel. But this is just the beginning. The vehicle often functioned as a mobile fire support platform when fitted with Browning 50 caliber machine guns. Transition to the next level. The utility of the frame allowed it to be adapted for multiple combat roles by Allied forces throughout various theaters of operation. It only looks obvious that such machines would be scrapped after the cessation of hostilities, but in reality, some survived in the most remote corners of the globe. A particularly notable example was discovered decades later at an abandoned airfield located in Tunisia. The equipment gradually disappeared under the sand near the structural remains of a makeshift hangar that once served as a tactical supply base. One can notice the faded paint on the armored side, where the inscription Baston Express remains barely legible to the eye. The cab of this specific unit had been repurposed by local shepherds to serve as a permanent shelter against the elements. It is visible how the metal surfaces weathered the transition from a dynamic combat vehicle to a stationary structure. Parts of the rear tracks remained protruding from the earth, marking the spot where the mechanical hybrid finally came to a halt. This discovery serves as a physical record of the North African campaign and the subsequent reassignment of equipment to the European front. The mechanical lifespan of the vehicle concluded at that airfield, but its presence preserved a specific historical narrative. Everything only gets more complicated when analyzing the strange engineering choices of the era. The transformation of raw steel into a functional battlefield hybrid is a process that ends with the preservation of these technical artifacts. The next stage of development focuses on a German transport with an even more unconventional silhouette. 55 horsepower was the total output generated by the specialized propulsion system of the Krupp Protze L2H143. Why did this light six-wheeled vehicle feature such an unconventional silhouette during its development in the late 1930s? The design prioritized a lowered chassis and a recessed driver's cab, which differed significantly from the standard military transport profiles of the era. This configuration, combined with a front-mounted engine, created a low-profile angular geometry that provided a technical advantage in concealment. The Krupp company engineered the vehicle specifically for the requirements of the Wehrmacht during the early stages of World War II. At the heart of the machine sat the Krupp M304 engine, a four-cylinder horizontally opposed boxer configuration with 3.3 liters of displacement. It is visible how the flat orientation of the cylinders allowed for the distinctively sloped hood line. While the power output remained modest, the engine provided the necessary torque to haul infantry supplies and light weaponry across varying terrain. A 4-speed manual transmission directed power to the rear wheels to maintain forward momentum. The suspension system utilized leaf springs specifically tuned to provide relative stability when navigating rough dirt roads and uneven landscapes. One can notice the agility of the chassis as it transitioned between transport roles, including ammunition delivery and the towing of light artillery pieces. But this was just the beginning of its operational history. The vehicle served as the primary prime mover for the 37mm PAC-36 anti-tank gun during high-mobility operations. Design features included an open cab and side-facing bench seats in the rear compartment to facilitate rapid deployment of troops. Everything only gets more complicated as the theater of war expanded, yet the truck remained a workhorse throughout the invasions of Poland and France. It was particularly common during the initial push into the Soviet Union before heavier logistics vehicles eventually phased it out. It seems simple to categorize the truck as a mere relic of the Blitzkrieg campaigns, but in reality, individual units found secondary lives in unexpected environments. One specific example was discovered decades later within a partially collapsed stone barn located near the border of Germany and the Czech Republic. The camera glides along the rusted frame where the vehicle had been integrated into a makeshift farm workshop. Surrounded by piles of scrap metal and discarded tires, the chassis remained structurally intact despite years of neglect. The most striking detail involved the modification of the original boxer engine bay for agricultural utility. The engine had been partially disassembled, and a thick, rough plank of wood was positioned across the bay to serve as a functional workbench. Equipment that once moved artillery through combat zones was repurposed into a stationary platform for repairing farm tools. Dust slowly settles over the iron components that once defined the mobility of an entire army. The transition from a high-speed military transport to a static piece of workshop furniture marks the final chapter for this specific unit. The mechanical mechanical components remain frozen in their modified state, reflecting a shift from tactical use to domestic survival. Thus, the steel reaches the end of its functional journey as a tool of history. 7 liters of displacement define the volume of the Maybach HL62 TUK engine powering the Sonderkraftfahrzeug 7. Designed in the 1930s by the manufacturer Krauss-Maffei, this German half-track was originally engineered for the specific task of towing heavy artillery pieces and transporting mechanized infantry across varying terrain. Why did this particular model become a fundamental element of the logistics chain throughout the entire conflict? While many vehicles were limited to a single role, the versatility of this platform allowed it to evolve into a mobile anti-aircraft battery and a multi-purpose transport system. It gets more complex further on. The inline 6-cylinder engine produces approximately 140 horsepower to move the vehicle's massive frame. One can notice how the mechanical power is distributed through a 5-speed manual gearbox equipped with a dedicated low-range gear for navigating difficult soil conditions. This transmission system utilizes a twin drive shaft setup to provide torque to both the steered front wheels and the rear track simultaneously. Such a configuration ensures that the vehicle maintains reliable handling characteristics on paved roads while surviving the stresses of off-road maneuvers. It only looks obvious to have such traction, but in reality, the balance between wheels and tracks required complex engineering to prevent the machine from bogging down under the weight of its cargo. The suspension architecture combines 2 distinct mechanical systems to manage the load. Leaf springs support the front axle, while the rear track system operates on independent bogies fitted with coil springs to absorb vibrations. This allows for a relatively smooth movement even when the 22-foot-long steel body is fully loaded. One can notice the longitudinal seating arrangement designed to accommodate 12 fully equipped soldiers within the sturdy metal chassis. Everything only gets more complicated when the vehicle is tasked with its primary mission. 12,000 units of this half-track were manufactured before the conclusion of the war in 1945. The equipment gradually became the standard prime mover for the 88mm flak gun, which served as a dual-purpose anti-aircraft and anti-tank weapon. Because of its structural rigidity, certain variants were modified to mount the artillery piece directly onto the rear bed, effectively turning the transport into a self-propelled gun platform. The process is only gaining momentum as these machines spread across every major theater of operations, from the arid deserts of North Africa to the frozen expanse of the Eastern Front. At first glance, the military history of these machines ended with the surrender, but in reality, individual units survived in unexpected environments. A single vehicle was discovered years later on a rural farm in Hungary, where it had been repurposed as a logging tractor to haul timber through dense forests. Although the farmer had modified the superstructure for civilian work, the original towing assembly and the heavy rear tracks remained completely intact. The camera glides along the chassis, revealing how the original military insignia was still visible as a faint outline beneath layers of red paint applied decades after the war. A machine that began its life as a centerpiece of heavy artillery ended its service as a humble agricultural tool. This transformation represents the final stage of its functional utility, moving from the front lines to the quiet routine of a rural farm. The next stage of engineering history involves a hybrid machine built for survival in the most extreme environmental conditions. 75 horsepower was the total output generated by the 3.6-liter inline 6-cylinder engine of the Opel Maultier. Why was such a relatively low-powered hybrid vehicle developed during the height of the conflict? On the freezing and muddy roads of the Eastern Front, traditional wheeled trucks were constantly bogged down and rendered immobile. This necessitated a bold mechanical solution that could keep moving when every other transport had stopped. The answer arrived in the form of the Maultier, a name meaning mule, which was based on the chassis of the standard Opel Blitz 3.636S. Engineers retained the standard front axle and steering wheels to maintain control, but they replaced the rear axle entirely with a track suspension system that drew its inspiration from captured British Matilda tanks. It only looks obvious that a heavy tracked system would require a massive engine, but in reality, the vehicle relied on a 4-speed manual gearbox and a low-range transfer case to compensate for its modest power. The Maultier was not designed for speed, but it could crawl through deep snow and thick mud where no standard wheeled vehicle could possibly find traction. One can notice how the rear track suspension utilized bogies equipped with coil springs for stability. Simultaneously, the front of the vehicle kept its original semi-elliptical leaf springs to handle the weight of the cabin. But this is just the beginning. The body of the machine was kept lightweight to maximize its displacement over soft ground. It featured a simple steel or wooden cargo bed, and depending on the specific production variant, it was fitted with either a soft top or hard top cabin. Everything only gets more complicated complicated when considering the sheer scale of the logistical crisis Germany faced. The simplicity of the Maultier design meant it could be produced with extreme speed and repaired easily in field conditions. It served primarily across the vast territories of the Soviet Union, handling critical rear-line logistics in regions where regular trucks failed to operate. The unusual aesthetic of the vehicle was outweighed by its mechanical reliability and its ability to adapt to the harshest environments on Earth. These specific traits made the machine beloved by the field crews who depended on it for survival. Many of these specialized hybrids were destroyed or scrapped immediately after the war, which makes any surviving examples incredibly rare to find today. One of the most notable discoveries occurred in an abandoned warehouse located in Ukraine. The vehicle was found buried under heavy tarps and piles of wooden crates, where it had been used as a makeshift structural support inside a farm tool shed for decades. It is visible how the passage of time affects such machinery, as the tracks themselves were completely gone upon discovery. However, the rear bogie setup remained remarkably intact despite the neglect. Experts who examined the wreck later confirmed it was an early production model that utilized parts taken directly from Matilda tanks captured during the North African campaign. Few vehicles better represent the era of wartime improvisation than the Opel Maultier. It was not a visually appealing machine and it was not particularly powerful, but it performed its assigned task under impossible conditions. The process of discovery continues to reveal the hidden history of these mechanical hybrids. Now the narrative reaches the top of the list to examine the strangest, most improbable, and perhaps most brilliant truck to emerge from this era. This final example represents the absolute peak of unconventional engineering. 1942 was the year the GMC company in the United States developed the DUKW 6x6, a machine that transcended the definition of a standard truck. This vehicle represented a bold leap in military engineering, specifically designed to function with equal efficiency on solid ground and in deep water. Why did the engineers settle on the peculiar name DUKW? At first glance, it appears to be a random phonetic choice, but in reality, it followed a strict internal GMC technical code. The letter D signified the model year of 1942, while U indicated a utility configuration with a dual axle. The K represented the all-wheel drive system, and W stood for the dual rear axles that provided the necessary traction. A GMC 270 inline 6-cylinder engine provided the mechanical heart of this amphibious transport. With 4.4 liters of displacement, this power plant produced approximately 91 horsepower. One can notice how the mechanical energy flows through a 5-speed manual transmission equipped with a low-range gearbox. This system linked directly to a transfer case that distributed power to the 6 wheels on land and a rear-mounted propeller for aquatic movement. But this is just the beginning. The hull, constructed from naval-grade steel, ensured the vehicle remained buoyant while the leaf spring suspension absorbed the shocks of rugged terrain. It reached speeds of approximately 8 kilometers per hour or 5 miles per hour when navigating through water. The process is only gaining momentum as the technical features reveal themselves. It featured built-in bilge pumps to evacuate water and an integrated tire pressure regulation system. This onboard system allowed drivers to adjust air pressure for soft sand or hard earth, which was a cutting-edge technical innovation for the 1940s. Visually, the machine resembles a boat mounted on wheels. The camera glides along the sloped bow, the short windshield, and the high sides that lacked traditional fenders. The mission of the DUKW was critical for amphibious logistics. It transported troops and supplies directly from ships to the shoreline, removing the necessity for established docks or landing infrastructure. Everything only gets more complicated when considering its operational history. It played a fundamental role during the D-Day landings in Normandy and participated in major operations throughout the Pacific and Italy. Transition to the next level. After the war, these vehicles transitioned into civilian roles for humanitarian aid and post-war recovery missions. Decades later, a remarkable discovery occurred on a rural property in Poland. One of these 6x6 units was found half submerged at the edge of a lake, partially obscured by layers of algae and aquatic vegetation. Local residents claimed the vehicle had remained in that exact position since the 1940s, occasionally serving as a stationary fishing platform during the 1960s. It only looks obvious that such such a machine would be completely frozen by time. However, the rear propeller remained attached to the hull even after years of exposure. Eyewitnesses observed the blades rotating slowly with the movement of the water current, as if the internal mechanics had never truly ceased. The equipment gradually reveals its endurance through these small physical movements. This vehicle stands as a physical embodiment of wartime innovation, remaining simple and rugged in its construction. The DUKW proved brilliantly effective in the specific environments where its dual capabilities were required most. The material remains a testament to the engineering solutions of its era. 100% of the designs discussed were engineered to be effective in the specific environments where performance mattered most. Why were such unorthodox and strange configurations chosen for these vehicles? The answer lies in the harsh reality of the front lines, where standard equipment failed to navigate the terrain. This journey has uncovered far more than forgotten trucks, revealing machines constructed to solve real-world problems under the immense pressure of global conflict. These strange designs eventually earned a permanent place in history through their sheer utility. Everything only gets more complicated when analyzing their operational roles. These trucks functioned as mechanical solutions to logistical nightmares rather than mere modes of transport. One can notice how the equipment was forced to operate in environments where mechanical failure was not just an inconvenience, but a factor that could cost human lives. It seems simple to categorize these as mass-produced units, but in reality, their origins varied significantly. Some were engineered in the controlled environments of massive factories, while others were cobbled together in the field using available materials. Many were never intended to last beyond a single campaign, yet they endured through the resilience of their construction. The equipment gradually transitioned from temporary tools to lasting legacies of engineering. These machines are physical witnesses to a world undergoing a massive technological transformation. They remain legacies of resilience that captivate those who understand the value of functional design under extreme pressure. But this is just the beginning. The stories and experiences of those who study these vehicles add further layers of depth to the understanding of military history. Every week brings a new investigation into the most impressive machines ever built for war and survival on the extreme edges of history. Thus, the exploration of these mechanical solutions concludes for now, having documented the resilience of design under the most difficult conditions imaginable.